Welcome, everyone. Today we are exploring a terrifying new paradigm in cryptocurrency security. The impenetrable mathematical fortress of blockchain is under siege not by breaking cryptography, but by shattering the software layer. We're going to examine how Anthropic's Claude Mythos model has fundamentally disrupted decentralized finance. Let's get started. Let's kick things off by defining the threat landscape. Claude Mythos, developed under Anthropic's Project Glasswing, represents the Oppenheimer moment of cybersecurity. Now, a common misconception is that AI will crack Bitcoin's cryptography. That's entirely false. SJ-256 remains computationally secure. However, Mythos doesn't attack the math, it attacks the software implementing the math. We're talking about wallet firmware, ECDSA implementations, and smart contracts. Mythos acts as a completely autonomous, zero-day factory. Traditional tools look for known bad signatures, but Mythos reads the code, understands the developer's intent, and finds semantic logic flaws that automated fuzzers have missed for decades. It then autonomously chains these minor flaws together into a full exploit stack, completely bypassing modern security perimeters. Look at this architectural breakdown. On the left, we see the blockchain core, which remains secure. But on the right, the entire software layer is exposed. Claude Mythos applies deep semantic logic scanning to smart contracts, wallet firmware, and off-chain infrastructure. Notice how all these targeted vectors converge into an exploit stack. The AI isn't finding one magic bullet, it's finding multiple tiny holes in these different layers and weaving them together to orchestrate a massive breach. So, what is the primary target for this AI? Cross-chain bridges. Bridges are the vital tunnels connecting different blockchains, holding billions in locked liquidity. To understand the basics, you have to realize that a bridge isn't just a smart contract. It's a complex ecosystem of multi-signature wallets, relayers, and oracle networks. Why are they so vulnerable? Because they force a transfer of trust from the blockchain's native consensus to off-chain, centralized infrastructure. How does Mythos attack this? It doesn't just read the smart contract bytecode. It maps the entire ecosystem. As industry experts have warned, the biggest risks now sit in the infrastructure layer like key management and signing services. Mythos identifies the exact seams where data is handed off between an oracle and a smart contract, creating an attack vector that isolated security audits completely miss. This diagram illustrates a standard cross-chain bridge architecture. You have assets locked on chain A and corresponding assets minted on chain B, facilitated by the bridge relayer node in the center. Notice the critical dependencies, the Oracle network feeding state data, and the multi-sig signers validating transactions. The red dashed lines represent the Mythos attack agent. It isn't attacking the blockchain directly, it's surgically targeting the infrastructure seams, the oracles, and the signers, compromising the entire bridge ecosystem from the outside in. Now we get to the core exploit Anthropic identified, the temporal trust gap, or TTG. What is it? A TTG is a microscopic race condition, often spanning less than a millisecond. The basics are terrifying. There is a tiny window of time between when a smart contract validates a transaction and when it actually executes the transfer of funds. Why do human auditors miss this? Because humans read code statically. We assume validation and execution happen as a single, unbreakable atomic action. How does Mythos exploit this? Operating at machine speed, Mythos analyzes the dynamic execution of the code and identifies exactly when that sub-millisecond gap opens. In a deep dive scenario, Mythos injects a malicious state change right into that gap. The protocol validates a legitimate transaction, but right before execution, Mythos alters the payload. The system approves the transfer, but the money goes to the attacker. Let's walk through the sequence diagram to visualize the temporal trust gap. The legitimate user requests a transfer. The bridge contract performs its validation, checking signatures and balances, and marks it as a success. This is where the temporal trust gap opens. In that split second before the code executes the transfer, the Mythos agent intercepts the state and changes the destination address. The gap closes, the protocol blindly executes the cleared transaction, and the funds are routed to the attacker. It is a flawless, machine-speed robbery. Let's look at another major vulnerability class, semantic hallucinations. What are these? These are subtle logic errors often injected into codebases by developers relying too heavily on early-generation AI coding assistants like Copilot. The basics are that the code compiles perfectly. To a human auditor, it looks totally fine. But why is it flawed? Because early AI coders lack deep contextual understanding of DeFi economics. For example, let's look at a variable visibility error. A developer might intend for a user's balance to only be updated internally by the contract. However, the AI assistant generates the code as uint256 public virtual balance. By making it public, any external attacker can potentially manipulate that state variable. Mythos, being a vastly superior reasoning engine, actively hunts for these semantic hallucinations. It uses its advanced logic to find and weaponize the mistakes made by lesser AIs, turning developer convenience into a catastrophic security breach. This flowchart tracks the lifecycle of a semantic hallucination. A developer uses an AI assistant, which generates a smart contract containing a hidden logic flaw. Because the code syntax is flawless, it passes the human audit and gets deployed to the mainnet. Enter Claude Mythos. It performs a deep semantic scan on the deployed contract, instantly identifying the visibility error that the human missed, which leads directly to a state manipulation exploit. It's a perfect example of advanced AI exploiting basic AI. Now for a deep dive into the weapon of choice, the asymmetric flash loan attack. What is it? It's an attack where an entity borrows tens of millions of dollars, manipulates a protocol, and repays the loan all within a single blockchain transaction. The basics are wild. Flash loans require absolutely zero collateral, as long as the funds are returned in the exact same block. Why does Mythos use them? Because a flash loan gives the AI infinite capital to amplify the impact of a tiny Oracle logic error. How does it work? Mythos borrows $50 million instantly. It dumps that capital into a liquidity pool, drastically skewing the price Oracle. It then leverages the semantic hallucination we discussed earlier to drain the target contract at the manipulated price, repays the initial loan, and walks away with millions in pure profit. What makes this unprecedented is that Mythos fully automates the entire attack chain, writing the malicious contract, deploying it, and executing it autonomously in seconds. Let's trace the flash loan execution in this sequence diagram. The Mythos agent initiates a massive, zero collateral borrow from a flash loan provider. Immediately, it targets the price Oracle, dumping the funds to artificially skew the asset price down by 90%. With the protocol blinded by bad data, the agent hits the target DeFi protocol, exploiting a logic flaw to buy up assets at a massive discount. Finally, it rebalances the pool, repays the initial loan, and the transaction block closes. The entire sequence happens instantly, leaving the protocol drained. Let's apply this to a real-time, devastating use case. In April 2026, the crypto industry witnessed the Kelp DAO hack. This wasn't just a hack, it was an AI-driven cross-protocol contagion event, resulting in a staggering $293 million loss. How did it happen? An autonomous AI agent identified a temporal trust gap inside the bridge relayer mechanism connected to Kelp DAO. The agent executed an asymmetric flash loan directly through that sub-millisecond gap. But here is where the true nightmare of DeFi architecture reveals itself, the cascade effect. Draining that single liquidity pool instantly depegged derivative tokens used as collateral across the entire ecosystem. Liquidations triggered everywhere. The critical lesson here is that DeFi is deeply interconnected. A single, microscopic logic flaw found by an AI in one bridge can cascade and collapse entirely separate protocols in minutes. Traditional audits cannot predict contagion. This flowchart maps the anatomy of a contagion event. It begins at the top with the AI executing the TTG flash loan, resulting in the bridge liquidity being drained. That single event causes the derivative token to instantly depeg. Because DeFi protocols are stacked like Lego bricks, this depeg branches out, causing mass liquidations on lending protocol A and margin calls on protocol B. The paths converge at the bottom into total systemic contagion, erasing $293 million in value. Let's pivot to the deep infrastructure, because Mythos doesn't stop at smart contracts. Let's talk about side-channel attacks. What is this? A side-channel attack extracts secret cryptographic keys not by breaking math, but by analyzing physical hardware emissions, like power consumption or electromagnetic waves. The basics are simple: hardware is noisy, and it leaks information when processing keys. Why does Mythos excel here? Because Mythos-tier neural networks are extraordinarily good at finding patterns in massive amounts of noisy data. If you feed Mythos the sensor data from a hardware wallet executing a signature, it can actually reconstruct the private ECDSA key without ever touching the software code. Furthermore, in our deep dive, we see Mythos actively hunting for entropy regressions. This means it scans firmware updates looking for places where developers accidentally weakened the random number generator, allowing the AI to predict future keys. The infrastructure itself is bleeding data. This diagram shows a side-channel attack in action. The hardware wallet signs a transaction, executing a cryptographic operation. As it does, it inadvertently leaks physical data, electromagnetic noise, and power consumption fluctuations. This raw, noisy data is fed directly into the Mythos neural net analysis engine. Through advanced pattern recognition, the AI filters the noise, isolates the cryptographic signature, and flawlessly reconstructs the private ECDSA key on the right. The device's software was never breached, but the keys are stolen. To conclude, the era of static, human-speed security is dead. To survive, the crypto industry must transition to a machine-versus-machine defensive posture. The first step is Project Glasswing, an initiative where Anthropic provides defensive Mythos instances to top security firms. These defensive agents scan code 24/7, generating predictive patches before attackers can strike. Organizations must deploy autonomous SOCs AI-driven security operations centers capable of isolating threats in microseconds. You must implement dynamic session intelligence to monitor the behavioral intent of API calls, stopping AI agents in their tracks. Finally, the industry is building the Beacon Network, a real-time system that instantly shares adversarial AI signatures globally, creating digital herd immunity. We are in an AI arms race, and your infrastructure must adapt today. To master these cutting-edge security concepts, I invite all learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Thank you. Our final diagram outlines the modern AI defensive architecture. The defensive Mythos agent drives two main functions: continuous code scanning, leading to predictive patching, and dynamic session intelligence, which provides microsecond API isolation based on behavioral analysis. Both of these hardened outcomes feed telemetry into the Beacon network. The network then shares these threat signatures in real time, ultimately establishing global digital herd immunity across the ecosystem. This is how you survive the AI threat landscape.
To find related ebook and other material for this training course, go to quicktechie.com. Now you will see all the video courses are available here. So let's move to the ebooks. You can go here, ebooks, all AI related ebooks, like you are watching currently Mythos related training. That ebook would be uploaded under this section. You can download this ebook. PDF would be available, all 300-page PDF. So you just click on the download this entire ebook. You can download from this section. So whatever training you are currently listening, corresponding ebook would be available. We have thousands of ebooks available. Now, other than that, we have on video courses which you are watching right now. This also all AI related courses are available. Similarly, for all company related trainings are available, like Microsoft, you can find it here with their respective certification training modules. All exam simulators which would help you to get the certification preparation. Just refresh if you get this kind of error. Okay, so now you can see these are all certification preparation materials. Will also be click here to the NVIDIA certification preparation material. So you can see all NVIDIA certification preparation materials, and click on any of this and it would load the entire screen and you can launch the practice paper. So this is what you can see, that you can submit the answer. We have an audiobooks available. Okay, so for each section, and these are our alumni who can you can find out all alumni who are accessing our portal.